And so, Satish has curated the data and better understood the clinical context. He is, however, perplexed about his current model training results and seeks Mike's help.
Hey Mike, could you please help me understand what's happening to my model? I have it set up to train on the Derma MNIST dataset. There are 7 categories. I'd like to make the accuracy as high as possible. How do I do this? Can you help me out?
Sure. Can I check?
Yeah.
Satish?
Oh, sorry.
From your setup, I see you use accuracy, and it's around 66%, which is rather low and very close to a naive classifier.
So is accuracy the best metric? I heard of this other one called AUC. I don't know if that's better or if it should be used instead or along with. So how do you choose the right metric?
So accuracy can be sometimes misleading, especially if your dataset is not balanced. There's an extensive new review available called Metrics Reloaded, and I can recommend you have a look at that. So have you checked the balancing of your classes in your dataset?
Yes, in fact, based on our earlier discussion, I've plotted the label distribution, and it seems like one of the categories is much more prevalent than the others, which might lead to trouble. In fact, it's super dominant, it leads to about 60% of the total data set. Does this mean then that my accuracy results, the one I mentioned, 66%, is that just the network always choosing that one category?
Exactly, yeah, let's check that. So for this specific data set, do you know if there's already a benchmark available to see if, what kind of accuracy that's realistic for this task?
Yes, in fact, this particular data set, it's called the MNIST data set, and they have a website here which includes the accuracies and the area under the curve.
So it looks like 75% accuracy is a reasonable target to hit. So we can have a look at your training process and investigate how we could improve these numbers. So can you show me your loss curve?
Yeah, so here it is. In fact, you see it's after a while it kind of flattens out. I don't really know why. Does this mean that I've messed up the hyperparameters that I use for training?
Maybe. So let's investigate more. You could check for over or underfitting by plotting the accuracy and the training and validation loss during training.
Mike, I don't know how that's done really. I just copied the code from a tutorial and I haven't really messed around much with it. So would you mind helping me with the code as well?
Sure, but for that we can also ask Carmen. She's our in-house expert on that. Carmen, do you have a minute?
Yeah, sure.
Thanks a lot for your time.
Yeah, sure.
So Satish is new to the whole logging and training monitoring, and since you have a lot of experience, maybe you can show us some tricks how to do that.
Hey Satish.
Hello.
Do you use TensorBoard to log your results? How do you extract your experiments?
I do not currently. I just look at the training loss and curves at the end of the experiment. Could you let me know how it could be done better with TensorBoard maybe?
Yeah, sure, let's have a look.
So here it goes. TensorBoard helps to organize the dashboard for online tracking of training. You can plot while training and manage multiple experiments and compare how things change. If you use the summary writer, you can rerun experiments and generate multiple charts and check which one is the best.
Thanks Carmen for your help. This is fantastic. Do you also have suggestions on how to track and modify training hyperparameters while hopefully improving the performance?
Sure. The first few things to consider are: what is the loss function? Does it match your problem? What optimizer do you use? Is it known to perform well across the hyperparameter space? Is the model you are using sufficiently capable of representing the data distribution?
Okay, so we have improvements and can go to around 75% accuracy with larger CNNs and some tweaks to the hyperparameters. This is great. How do we go further? Is there a next magic bullet to try?
Well, to start simple, don't do regularization at the outset. Overfit on a small set and then make things more complex. You can add regularization, make the model more deeper or complex, and follow this iterative investigation process. And you could try as well data augmentation.
But how does one know what augmentation works and what doesn't?
For medical images, augmentation has to be done carefully. Depending on the problem, some augmentations are improper. For example, shearing when anatomical shapes are meant to be preserved is not the best idea.
Thank you so much for the tips. This is very helpful and very useful. I'm hoping to incorporate all of it in my model next.
Of course, no problem.
Sure, happy to help and good luck for the next steps.
And so, Satish strives and strives and strives. Satish contemplates his results and looks forward to the next step of model validation.